want everyone to take a look at the review here. The other sheet we'll go through at the end, but the major focus today is that you understand everything on your review. Okay, your quiz is going to be tomorrow on this material that's covered on this review. The story problems that you should know how to complete for your quiz are on the back of the review, those two. The other ones won't, the other type won't necessarily be on your quiz there tomorrow. Okay, so I want to make sure everyone's read through each set of instructions. If you haven't done so, do that now. Problems, are there any problems on here that you're not exactly sure what they're asking? What's being asked for you?
I know it's asking, I just I don't know how to do it.
Okay, we'll go through, we'll hit that here in a minute. Okay, so how about on the other side? Any questions you're not sure what they're asking? You now had time to work on the front side, so let me put up some of these answers. Now the answers are on the board there as well, but going through and at least looking at 1 through 3, there you've got it. 1, 2, and 3, check those. Any questions on 1, 2, or 3? Okay, here's 4 and 5. The graphs of 4 and 5. Check those out. You'll notice on number 5, the A term is 1/4. So once I've got my vertex of 5, 0, rather than going over 1 and up 1 times A, which would be a quarter, I went over 2, and where I usually go up 4, I've got to multiply that by A, which is a quarter. So a quarter of 4 is 1. All right. Then rather than going up over 3 and up 9 times 1/4 or 9/4, I decided to go over 4 and up 16 times a 4, which is 4. Okay. So when you have that fraction, it's nice if you go up, or if you can use your patterns that are divisible by the denominator. You can always make your table of values as well. Okay. We've got the vertex, we've got our x equals, make sure you have x equals there, or else it's not correct. An additional point, one additional point, I listed a couple of them. And then writing it in standard form, number 4, x squared, y equals x squared plus 4x plus 7. Make sure it's y equals. Okay? And number 5, y equals 1/4 x squared minus 5/2 x plus 25/4. Once again, make sure it's in y equals form. So this will be up on the board. It's also good. It'll be online. This is being recorded right now, so you can watch the video of it if you want to see the answers again when you're at home. Number 6 and 7. Okay, these tend to be some that students forget. My suggestion to you is first you check your notes. You've done this in your notes. Okay, it'd be on 5, 1, 2, or 3. I think this was actually 5, 2. Okay, so I've used reduced row echelon form here. It said if ax squared plus bx plus c equals y, my coefficient of x squared is a. That's what I'm trying to find. So I take my x squared, negative 2 squared is 4, 0 squared is 0, 3 squared is 9, and the coefficient of b, or of x, is b. So I'm trying to find, the coefficient of b is x. So I plug my x's in here. And then coefficient of c is 1. So I'm trying to find c. I put my 1's in. And then equals y, I put my y values in, 3, negative 7, and 38. Do reduced row echelon form, I get my identity matrix, which tells me A is 4, B is 3, C is negative 7. I've got it in that form. For those of you that want to use list format, remember you can call all your x values list 1, all your y values list 2, and then from there you would end up using quadratic regression on it. Okay, so your quad regression. I don't know what option that is on your calculator, but I do know that we went through it in class, so you can look back at your notes and see that as well. Okay, so questions on those two there? How many did pretty well on that side overall? Okay. Well, if you have any questions and while you're working on the other side and you still have questions about this side, you can talk to me. So I'm going to give you about another 10 minutes or so, maybe 15 minutes to work on the other side. Do your best. You can check your stuff on the board as well. All right, so page 2, here are the answers. Let's go through those. There's number 8 and 9. Okay. So you'll notice on number 8, the first thing you have to do is get it into vertex form. So you find h by doing the opposite of b over 2a. So you get negative 6 over 2. And that ends up giving you negative 3. You plug that negative 3 into x to find k. So that gives you negative 3 squared or 9. 6 times negative 3, negative 18, plus 4 gives us negative 5. So your vertex is at negative 3, negative 5. Meaning your axis of symmetry is at x equals negative 3. And then your additional point, there could be multiple ones I plotted there. Then changing it to vertex form, remember your a term is the same. So it's 1 here, so that means a is going to be 1. You have plus 3 minus 5. Okay, make sure you have the y equals and you put the squared there. Okay? Any questions on 8? Number 9? Number 9 is going through the same process. I'm just going to move it over so it's a little clear, more clear there. Okay, opposite of b over 2a, you get 2. Okay, mine's a little messed up. It's from my old version. But we put the 2 back in. 2 squared is 4 times negative 7, which is negative 28. Make sure you multiply, you square the 2 first and then multiply by negative 7. Don't multiply by negative 7 and then square. That's a common error, see? Okay, 28 times 2 is 56, minus 29, k is negative 1 then, so we get the ordered pair 2, negative 1 for hk. Axis symmetry, x equals 2, make sure you have that x equals. An additional point, 1, negative 8. Okay, 1 or 3, negative 8 would work. And then vertex form, negative 7, that's our a term, times x minus 2, quantity squared, all minus 1. Any questions on that one there? Good to go? Okay, very good. All right, number 10 then. And then we'll get to those story problems that everyone loves so much. Let me get a piece of paper to kind of blot those out there. All right, so number 10. Given those 3 points, or given, the vertex and the xy, write our equation. So we use our vertex, our hk, 4, 3, and our xy value and put it into y equals a times x minus h quantity squared plus k. Okay, we plug those in, our x, our y, our h, our k. We solve for a. We get a equals 2. So remember, you need to know a, h, and k. We've got them now, so there we have it in vertex form. Questions there? All right, very good. So story problems. These are the ones that tend to be a little more complex. So before I go through them, let me at least put up the answers so you can reference those. Okay, so on number 11, this guy right here, the solution is 30 feet by 60 feet. I know that helped by focus. Let me see if I can move that up and if it'll make it better. Focus there. Not really. Beautiful. All right. Well, here you go. 30 feet by 60 feet. Okay. The process you need to go through, there's all the work, which will also be, you'll be able to kind of check out online. But that's all of our work. And I'll go through the whole problem here. But all right. So you have this pin. A pin's to be constructed alongside a barn. So first thing you need to do is draw your barn. This is my barn. or at least the side of my barn. That way I don't have to show off my artistic skills. Okay, there's the barn, and I'm drawing a pin. Now, it probably would have been better if I actually told you that this pin was a rectangular pin. Here's my pin. Okay, I'm going to draw a rectangular pin off this barn, like so. And I know, based upon what they've told me, is I'm using 120 feet of fencing. In order to make the area of the pin maximize, what should the dimensions be? Well, I want to maximize it. I'm using 120 feet of fencing, so what I'm going to do is I'm going to call this length right here, my width, I'm going to call it X. Okay? If that's X, tell your neighbor what else you know. You can tell Alex. That's okay. Okay, yeah.
The side parallel to X is X too.
Yeah, this side parallel to it is also X. Okay, so I have X. I have X. Now, I have 120 feet of fencing, right? If this is X and this is X, what is this?
Y.
It's not Y. I want to go in terms of X.
X, 2x?
Not 2X. Good, yeah. So if I have 120 feet of fencing, and I've used X of it here and X of it here, that means out of my 120 that I had, I've used 2X of it. That means I have 120 minus 2X left. Okay, so there are any questions on what I've done there? Yeah, Ethan?
Wouldn't the other side also use some of the 120 though?
Right here?
Yeah.
It's next to a barn.
So
Don't need fencing against the barn, right?
okay.
Because unless those are some powerful whatever you're putting in there, I mean, they'd be like running through the barn.
Or like
Okay.
messing up a barn.
So we won't need the fencing there. Only need 3 sides. Okay. So we have this dimension, and the reason we didn't use Y or something here is or Y, excuse me, not Y or okay, but the reason we didn't use Y right here is because then it's not in terms of X. So to find area is equal to length times width. Okay, so this problem says in order to maximize the area of the pin, what should your dimensions be? Well, right now I'm dealing with a width of X and a length of 120 minus 2X. Okay? I probably should have made this a little better, so we'll bring this X right here. Okay? That's equal to my area. Okay, so X is our width. A equals 120 minus 2X times X, so we can use the distributive property here. That times that, and that times that. That ends up giving me 120X minus 2X squared. And we'll move it around so we have negative 2X squared plus 120X. Now, you guys have just been following along, assuming I know what I'm talking about, I guess. Okay? Why am I actually going through this? Like, it says, the question is, in order to make the area maximum is a key word, that's a hint for your story problem page. Anytime you see the word max or min, what are we talking about with a quadratic? Yeah.
The way it opens up or opens down.
Kind of, yeah. You're talking about the vertex. So this parabola, I really have no idea, like graphically, what it looks like. But let's say this is my vertex. I know it opens down because it's a negative a. So let's say this is my parabola. This point right here is called a, other than vertex,
Minimum. Maximum.
this is a maximum. So as you're applying this stuff, that's a max. That's what we're looking for. This is area on this axis. This is X on this axis. I'm looking for my maximum. My maximum what?
Area.
In order to make the area of the pin a maximum, okay, so, well, if I know that I have my maximum area there, I want to know the dimensions. What should the dimensions be? So here, if I find a maximum area, the other coordinate is a x, and x represents our, what does x represent here?
Width.
Represents the width. So if I can solve for x, I will know the width. That will give me one of my dimensions. Is a my other dimension?
No.
No, that's the area. What's my other dimension?
Okay. Over y.
120 minus 2x.
It's 120 minus 2x. Okay, so if I find x, that's great. The a doesn't tell me my other dimension. This does. Okay? All right, now some of you tuned out. I saw some of you start looking off. You're like, dude, he's seriously talking about stuff that I don't care. I'm not going to build a pin. So, okay. So this is application, right? This is when you might use this. Now, obviously, if I'm building a pin like this, I'm not probably cranking out my math like this. But you may use it when building something where you can't directly measure it as well and applying a maximum. So in this case, let's go ahead and solve for x. What do I need to find?
Okay.
Yeah.
Don't you do opposite of b over 2a?
Yeah, I'm going to find h, right? Opposite of b over 2a. That's my special x value. Opposite of b over 2a. So in this case, negative 120 over 2 times negative 2, or negative 120 over negative 4, which is 30. X equals 30. And we're dealing in feet, I believe, here. Yep. So 30 feet. If x is 30, what's our length? Yeah, it's 120 minus 2 times 30, which is 120 minus 6, minus 60, which is 60. What are my dimensions? Well, they're 30 by 60. Now, some of you, and I know this because you're my average Smarty Pants Trig students that I've had for the last 9 years, which is good. That's an endearing Smarty Pants term. Okay, but some of you are sitting there going, I didn't do any of that, McCoy, and I got 30 by 60. Ha ha! I didn't have to do any. I just guessed and checked. I'm the man, or I'm the woman. Very true. You could have guessed and checked, and you might have actually got the right answer. It doesn't stay that easy. Understand how to utilize and apply the idea of maximum and minimum and what you're actually doing. Get a conceptual understanding. Going through life, guessing and checking, especially when you're like building something, is an expensive way to go. Okay? Now, look at your neighbor. If they guessed and checked, tell them not to do that. Like, actually try the problem. And then also, if they have their earbud in, take their earbud out, because they are about to cost everyone in the class the right to have music.
Come on, Sam.
Okay, number 12. Number 12, the answer is y equals negative 3 over 4,000 x squared minus 3/10 x. So once again, the answer is y equals negative 3 over 4,000 x squared minus 3/10 x. Now, that didn't focus at all. Now, there's the work for it. Once again, I'll go through it. It actually will be a little shorter than this problem. That doesn't seem like that, because you look at that answer, you're like, what? Okay. I guess I should have said, are there any questions on 11 first? Or start 12? Okay, 12. You estimate the ball you hit reached its maximum height of 30 feet, about 200 feet from you. Write the equation for the flight of the ball in vertex form. Then rewrite it in standard form. Okay, so vertex form, the equation was y equals negative 3/4,000 times the quantity x minus, I believe that's a 200 squared plus 30. Yeah, it is 200 squared plus 30.
Plus 200?
No, it's minus 200. Quantity squared plus 30. Now, if you're doing this problem, if they ever say, hey, you do something, imagine you do something like you're hitting a ball or you're driving a car, you always start here. Why? Because that is the easiest place in the coordinate plane to start. It has a coordinate of 0, 0. You like it because it's easy to start there. You hit a ball. Okay? This ball reaches its maximum height of what? 200 feet.
It's pretty good.
Is it 200?
No, it's
No, 30 feet. Maximum height of 30 feet.
It's not as good.
200 feet from you. So that tells me my vertex, because a hit ball or a thrown ball follows a parabolic shape, is the ordered pair 230. That has now told you your HK. How convenient is that? Dude, so now you know if I'm writing an equation, I have y equals, in vertex form, that's easy. X minus h quantity squared plus k. We know HK. We need A. We know h is 200. We know k is 30. We need to find A. Okay? So to find A, we plug in another xy point. Well, it's convenient that we're standing at the origin, which happens to be on our parabola, because now we have y equals, or actually for y, let's make that 0. 0 equals A times 0 minus 200 squared plus 30. And 200 squared, negative 200 squared is 40,000 plus 30. So we have 40,000 times A plus 30 equals 0. Subtract 30. We'll be able to find A pretty easy. We get 40,000. A equals negative 30. So 1A is negative 30 over 40,000. Simplify, reduce it by a factor of 10 by canceling a 0. We get 1A is equal to negative 3 over 4,000. So my equation in vertex form then, y equals negative 3 over 4,000, x minus 200, quantity squared plus 30. Standard form, you just got to multiply it out. Oops. Square it first, unlike what I was about to do. So there's vertex form. Standard form, you got to multiply out, which I've actually done right here. Okay, that x minus 200 squared is this, times that, plus that, brings you to here. Quick note about your